All right. So once again, you are welcome. Today we're looking at Module 2 and Module 3, switching concepts and VLANs. Now, what is a switch? We tend to ask this question, what is a switch? And a switch is basically a network intermediary device, okay, that receives frames. The PDU at that level is called a frame. The switches also functions at layer 2 of the OSI model. So it's a multi-port internetwork device that receives and forwards frame and also manipulates this frame. Okay, so we are going to be looking at basically how these frames are being forwarded, and then this will compare the collision domains and broadcast domains. Those are like the switching domains that the switch has. So we're going to understand those concepts. So what is frame forwarding? First of all, we understand that the frame is our data at functioning at layer 2. If you remember your OSI model, all right, in your OSI model, we said that you have 7 layers, and layer 2 deals with switches. Layer 3 of that model deals with our router, which is the network layer. Now, these switches that we're talking about that functions at layer 2, it deals with the data called frames. And so the frames, as they come into the data, we call them ingress. Okay, the interfaces that the frames use to come into the data, the switch, we call them the ingress interface. Then the interfaces or the ports in which the switch takes these frames out of the switch is called the egress. So these two terms are the ones basically associated with frames as they come into the switch and as they go out of the switch. Okay, so the switch does this forwarding based on source and destination MAC address. Okay, now in CCNA 1, I'm sure you were also taught about the frame header. All right, it has a header and it has a trailer. And there are some information that probably we need to know, of which I know we already know. But fundamentally, in that frame header, it has what they call the source MAC address and it has the destination MAC address. Okay, now the source MAC address tells where the ingress is coming in, where the receiving device, okay, the MAC address of the receiving device. Then the destination MAC address is the MAC address of the destination device. All right, the next hop or the next device or the receiving device that is supposed to be receiving this particular frames. So the switches makes its decision based on the MAC addresses that it has. Now, how does it know of these MAC addresses? It has what we call the MAC address table. All right. Sometimes it also has what we call the content management or content addressable memory. All right. So the switch builds this MAC address table and it builds it at startup. Once the switch starts, the MAC address table is virtually empty. But as the end devices connected to it begins to send frames, begin to send messages, all right, they generate the MAC address table is basically built up. Okay, so that is how it actually builds that particular MAC address table. But how does it learn it? Okay, now step 1 says that the switch learns and examines the source MAC addresses. All right, and then after it examines it, it adds the source MAC address into its table and then resets the timeout, setting back to 5 minutes if the source in the table. All right, if the source is in the table. All right, so the point we're making is that my switch at initial point, when I start the switch, it has a MAC address table, but there's nothing in it. So if my end device, my laptop, my desktop, or whatever device that I have connected to the switch in that particular port makes the first initiation of sending a frame, okay, it's trying to send a frame, of course, the switch trusts the source in which it comes in. All right, because in the frame there is a source MAC address and there is a destination MAC address. So the switch will now trust the source of its MAC address so that by the time it is sending it, it's going to document the source MAC address in its table and it will map it to the port number that it is receiving it from. All right, and that is basically the first way it learns, it builds its MAC address table. All right. Now, step 2 says that it examines the destination address. So, if the destination MAC is in the MAC address table, it is forwarded out to the specific port. But if the destination MAC address is not in the table, it is flooded out all interfaces except the one it receives. Let me show you something. Okay, now this is the 2960 switch series that we're talking about, and the point we are saying is that this switch as it is does not have, if you power it, it has a MAC address table, but it is empty. Okay, so if my system, I pick a system and I connect it to the first port, all right, if I pick a system and I connect to this port. Now, I am trying to explain the step 2. It says that if I am trying to send a frame or a message to another system that is connected to a different port here, for instance, what happens is that if my system sends the message coming from here, this switch is going to now store the MAC address of my system in the switch. And it's going to store it, this is port what? Okay, this is port 24. So it's going to store it under port 24. There is a MAC address 00ABCDEF or something like that, okay? Now, once it's sending the message to another device, maybe the device is in port 13 here. Now, port 13, if port 13 is in the MAC address table of this switch, what the switch will do is just that the message goes from here and automatically comes to this port straight away without any flooding, without any problem, comes to this switch and delivers the message. But the moment that it sends the message with a destination that is on this particular port, and unfortunately the MAC address of the destination device is not in the table, what the switch will do is that it will send the message to all these ports, all the ports on the switch. So once it sends it to all the ports on the switch, what it means is that every port will check the destination MAC address that is in the frame header. If it matches its own MAC address, then it will receive it. But if it doesn't match, it will discard it. So there is only one that will match, which is the destination device that is located here. So all of this, none of it will respond to the message, except the guy that has the destination, that has the MAC address of the destination device. So this is the guy that is going to respond back. And in responding back, this switch is now going to store, the MAC address of the device to that particularly corresponding port. Now, how does the switch does its forwarding? How does it forward its frames? All right, there are two major methods that it uses. One is called the store and forward. The other one is called the cut through method. Okay, now in the store and forward, what it's saying is that the switch will receive the entire frame and ensures that the frame is valid. All right, then store and forward switching is actually Cisco preferred switching method. Why? Because once it receives it all, it will make sure that there is no error in the frame. Remember your CCNA1 in the frame header, the trailer, it has what we call the FCS, the frame check sequence. That is where it checks for errors associated to that particular frame. All right, if there are errors in the frame, that is where it's going to be located, and that's where we are going to, the switch is going to now verify. And how does it even know whether there are errors? It's going to calculate, or there's one they call CRC, cyclic redundancy check. It's going to calculate the size of the frame, all right, and correspond it to the size in which the sender says the size of the message is. So within that particular frame, there is the size of that particular frame, or the size of the data. So if the FCS or the CRC checks the sizes and then discovers that it is not the same, then it's not going to forward the message. All right. But if it is the same, all right, then it means that the message has not been altered, and then it's going to now send it. All right. That's the store and forward. Now, the other one is the cut through switching. Now, it forwards the frame immediately after determining the destination MAC address of an incoming frame and the egress port, meaning that the moment it starts receiving this particular frame. As it's receiving the frame, it receives the destination MAC address, and then it now gets the egress port. That is, the port that is going to forward the frame is going to just begin to start forwarding it. It's going to start forwarding it immediately, even if there are errors on that particular frame. All right? Now, one of the difference between the two is that, you see, a cut-through does not need to wait for the entire frame to reach the switch before it begins to forward. So thereby making it faster in the forwarding. All right? And the store and forward, actually, it's a bit slower, but it has more data guarantee. Why? Because it does error checking, all right? And it also does buffering, all right? So the ingress interface will buffer the frame while it checks the frame check sequence, all right? This also allows the switch to adjust to a potential difference in speed between the ingress and the egress ports, all right? But the cut through forward in the other side, we call it a fragment free, all right? Free method will check the destination and ensure that the frame is at least 64 bytes, all right? It's at least 64 bytes. And in the 64 bytes contains at least the destination MAC address and then the preamble. All right. So the concept of cut-through method is that it is appropriate for switches needing latency to be under 10 microseconds, and it does not check for errors. All right, and it may lead to bandwidth issues if the switch propagates too many errors. All right. So so these are some of the advantages and disadvantages of this particular methods, the cut through and then the store and forward. Now, how about what we call the switching domains? All right. Now, the switch eliminates collision domains and reduces congestion. All right. So when there is a full duplex on the link, the collision domains are eliminated. So when there is one or more devices in half duplex, there will now be a collision domain. There will now be contention for the bandwidth. All right. So collision is now possible since we have a half duplex. All right. So most devices, including Cisco and Microsoft, use auto negotiation as the default settings for duplex and speed. Duplex now is either is half duplex or full duplex. So you set it to auto, all right, by default, but you can change it, all right? The speed now either has to do with whether it is 10 Mbps or whether it is 20 Mbps, 100 Mbps, or a gigabit, 1,000 Mbps or so. All right. So if you set it to auto negotiation, it is going to adjust the settings of the port or the settings of the interface. All these things is to avoid collision. All right. How about broadcast domains? So a broadcast domain extends across all layer 1 or layer 2 devices on a local area network. All right. On a local area network. So only a layer 3 device, which is a router, all right, only a layer 3 device will break the broadcast domains, also called the MAC broadcast domain. Okay, now the broadcast domains consist of all devices on the local area network that receives the broadcast traffic. Now, when the layer 2 switches receives the broadcast, it will flood it out through all interface from the name broadcast. That's what basically it means, except the ingress interface. Ingress is except the port that receives this particular frame. So too many broadcasts may cause congestion on a poor network infrastructure. All right, too many ingress may cause congestion. So increasing devices at layer 1 or layer 2 would cause the broadcast domain to expand. Now, let me give you an instance. Here in my office, there was a time we set up a network, and we segmented the network into different broadcast domains. But there was a particular broadcast domain that had, let me say, 2 switches. No, not 2 switches, 4 switches, 4 24-port Cisco switches. Now, in each of these 4 24-port Cisco switches, there are like 4 access points. 4 access points. So you see, there are like a total of like 16 access points on that particular single broadcast domain. Apart from the end devices like the desktops, the laptops that are on that particular domain. Now, we had a lot of traffic at a particular day. So many people were connected. The organization had a lot of visitors, so we gave them access. And for each of those access points, we had like about 70 end devices connected to it. Mobile devices were connected to each of those access points. Now, you could imagine the size of the broadcast that will be generated within that particular broadcast domain. Because each of these particular access points has about 70, 60, 70, 80 end devices connecting, and each of these devices is sending its own broadcast. You can imagine for those switches, how many broadcasts is sent for each of those particular ports, multiplied by 4. And the resulting implication was that we noticed a high level of network congestion. There was a lot of traffic congestion. The network became frustratingly slow. Now, at first, we didn't know what the problem was until we came to investigate and troubleshoot. And we discovered that it was the size of the broadcast. So all we needed to do was each of those switches, we now placed them on different broadcast domains. And it dropped down drastically the size of the broadcast that was being generated and the collisions that were there. So look at this image, for instance. You see, this is switch 1, and it has, let's assume it's a LAN on its own, and it has a broadcast on its own. So it has end devices and probably a server within it. Okay, and then you look at this one also. It has something similar, but there is an extension. There is an extension. So you see, this is, for instance, a 24-port and has many devices connected to it. Then one of the egress ports here, one of the ports here is extended to another, one of the ports extended to another switch that is 24-port. So this switch that is 24-port This switch that is 24 port is actually generating its own broadcast. So imagine that you now extend it again and extend it again and extend it again. What it means is that at the end of the day, the entire load will be coming into this particular port that is here. All right. So when you have too many of such broadcast domains, definitely is going to affect the types of traffic that you generate. Now, so let's quickly go into VLANs. All right. Now, there's so many lab activities here, but like I said, we'll try and see how much we can cover. If we can cover all, great. But if we can't cover all, well, we'll find a way around it. All right. So VLANs. What is a VLAN? A VLAN is a virtual local area network. All right. It's a VLAN is a virtual area network, and they are logical connections with similar devices. Look at this building, for instance. Now, in this building, let's say this organization or this office complex, they have a router. Probably let's call it the core router. Then they have a switch. Let's call it the core switch, for instance. All right. Now, within this, they have different floors. The first floor, the second floor, the third floor. Now, within these floors, you have switches. And each of these switches, you have different departments in each of these floors. All right. You have different departments in each of these floors. You have different devices on each of these floors. And they are all connected to this particular switch. Okay. The same happens to the second floor. The same happens to the third floor. Now, instead of getting a router, let's say like 3 routers to serve maybe IT department, serve human resource department, serve sales department, because maybe you wouldn't want human resource to have access to services in sales. Sales should not have services in IT and things like that. So instead of having a router to segment all this network individually, the cost is going to be high. The network management is going to be complex, especially for the network administrator. And you will not have a centralized management, easily managed centralized centralized management system. Okay. Your network would be difficult, complex, expensive, and less effective. All right, but it would be equally good. But the proper way to do is just to have one single router that will segment each of this. All right, one single router that will segment each of these particular departments or these particular networks, because this IT is a particular network and it exists on each of the floors. Human resource, each of the floors. Sales in each of the floors. All right. So VLANs actually will provide segmentation of the various group of devices on the same switch. So you have these devices connected to the same switch, but the VLAN will actually provide you with good segmentation. All right. And it will also provide organization that is more manageable. All right. A very more effective, manageable organization, especially in terms of broadcast and multicast and unicast on that network. And each VLAN will have its own unique range of IP addressing. And then at the end of the day, you might be having smaller broadcast domains. All right. Smaller broadcast domain. So what are some of these benefits of a VLAN? One is that the VLAN gives you a smaller broadcast. That means you would have a lower latency to your network. Okay, you have lower latency of traffic to your network. Then you would also have improved security. All right, so only users within the same VLAN can communicate to each other. If you just connect to just the single domain, you would have problem on that. Then you also have improved IT efficiency. It's also a very good benefit, especially to network administrators. Okay, so VLANs can group devices with similar equipments or requirements, all right, e.g. students or faculty or staff or guests, or maybe based on departments, or maybe based on courses, anyway, based on peculiarities of your organization. And then it's also going to reduce costs, especially cost of buying each of these equipment. Buying a router or a switch, manageable switch or routers, they are quite expensive, all right? They are quite expensive, so it will reduce this number. Now, it's also going to give you better performance because small broadcast domain reduce traffic and improved bandwidth connectivity, which is absolutely true, okay? So it's also going to give you simpler management. So these are the benefits that you have for VLANs, all right? Now, we have different types of VLANs. The first one is the default VLAN. Then we have the default native VLAN, then the default management VLANs. Now, what are these defaults? We say default because as you buy the device, the switch, it comes with it already configured by default. For instance, in this particular switch, I do show VLAN brief, and you'll see there is a VLAN 1, and all the ports are connected to this VLAN 1, and it is by default. You didn't create it. Just by purchasing the device, by powering the device, you discover that you have it. You didn't create it. So that is why it is default. Now, every switch, every Cisco switch has this as its default. And that is why one of the security things that is advisable is that do not make use of your default VLAN, because anyone who knows that every switch has a default VLAN called VLAN 1 might make attempt on your device. All right. Then we have the data VLAN. Data VLAN is dedicated to user-generated traffic, maybe emails and web traffic. So VLAN 1 is the default data VLAN because all interfaces are assigned to this VLAN. That same VLAN 1 is your default management VLAN. Okay? Now, what is the native VLAN? This is used for trunks only. All right? Now, we're going to be talking about your access ports and your trunk ports. And we'll find out the difference between these two. All right? So, the native VLAN, all frames are tagged on the 802.1q trunk link except those on the native VLAN. All right? Those on the native VLAN are basically for trunk. All right? So the management VLAN is used for SSH or for telnet or for when you want to remotely gain access into that particular device. All right? For traffic. So this is used for SSH, telnet, VTY traffic, and should not be carried with end user traffic. All right, so typically the VLAN that is the SVI, switch virtual interface for the layer 2. Okay, so these are the three that we are looking for. Then we have also the voice VLAN. Now, the voice VLAN is separate VLAN because it conveys what? Voice traffic. All right, it basically conveys voice traffic. It has high quality of service, priority on voice, and then it has ability to avoid congestion. All right, so the entire network must be designed to support voice. So VLAN is a multi-switched environment. Excuse me. So a trunk is a point-to-point link between two network devices. All right, so the trunk allows more than one VLAN and extends the VLAN across the entire network. And by default, it supports all VLAN except the trunking 802.1 trunking VLAN. Now, what is it that we need to know specifically here? What we need to note is that once you have created VLANs on your network, and traffic is moving from that particular VLAN, we call it tagged traffic. All right, tagged frames. It is tagged, and it is tagged with that particular VLAN. Now, once you say a trunk, trunks do not have, they are untagged. All right, they are untagged. So because they are untagged, they do not belong to a specific VLAN. All right, so if we configure a port as a trunk port, it means that it can convey all the VLAN information, all the tagged traffic. It can convey them through its own port. All right, but once a port is configured as a VLAN, all right, or as an access port, it can only receive tagged traffic that has tagged of that particular VLAN. Okay, so for instance, look at this image here. We have switch 1, switch 2, and switch 3. Switch 2 and switch 3 are connected to VLAN 1. Now, within switch 2, we have 3 VLANs: guest VLAN, student VLAN, and the faculty VLAN. Switch 3 has the same: guest VLAN, student VLAN, and faculty VLAN. And these 3 switches are in different locations. They are in different locations entirely. And so the point here is that if I send a frame or a message from a traffic from guest VLAN, that traffic is tagged as it comes to this particular switch. All right. If I send a message from student VLAN, is tagged. If I send it from faculty VLAN, is tagged. But this link that comes here that connects this particular switch and connects these ones, they are called the trunk ports. All right, the trunk links. And this trunk links carries all this tag traffic and passes them through. Carries and comes this way and passes likewise. Now, without VLAN, all devices connected to switch will receive all unicast, multicast, and broadcast. All right, that is without VLANs. So with VLANs, unicast, multicast, and broadcast traffic is configured to a VLAN without a layer 3 device to connect to the VLANs. Devices in different VLANs cannot communicate. What are we saying here? That if I have this particular guest VLAN, it can only communicate with another guest VLAN here. If I generate a broadcast here, it is only within this guest VLAN, because this is a broadcast domain, this is another broadcast domain, this is another broadcast domain. So the point we are saying here is that you cannot move from student VLAN to faculty VLAN without the presence of a router. Okay, without the presence of a router. Now, VLAN identification with tag. So when the tag is created, the FCS, which is the frame check sequence, must be recalculated. And when sent to end devices, this tag must be removed and the FCS recalculated back to its original number. All right, so it is within its particular frame header. Now, how about the native VLAN and the 802.1q tagging? All right, now tagging is typically done on all VLANs. All right, the use of native VLANs was designed for legacy use, like the hubs in the example. Okay, and unless changed, VLAN 1 is the native VLAN. Remember, it is like the default. So both ends of a trunk link must be configured with the same native VLAN so that they can have effective communication. So each trunk is configured separately, so it is possible to have a different native VLAN on separate trunks. Okay, different. So what you look at here, for instance, this particular switch here can have 802.1q here for VLAN 2 and 3 here. All right, then it has 802.1q here for VLAN 1 and 2. It has 802.1q here for VLAN 3, 802.1q here for VLAN 1. Okay, so that is the point we are making here. How about on the VoIP? So the VoIP phone, VoIP is simply voice over internet protocol. Voice over internet protocol. So the switch will use the CDP, which is the Cisco Discovery Protocol, to inform the phone of the voice VLAN. So the phone will tag its own traffic. All right, it will tag its own traffic. Just a minute. Let me. Okay. So we are saying that the phone will tag its own traffic voice and can set cost of service as quality of service also for layer 2. So the phone may or may not tag its frames from PC. So the point we are saying here basically is that depending on the VLANs you create, depending on the tagging you create, the switch is able to manage the traffic. Okay, whether it is tagged for voice, whether it's tagged for a particular VLAN, or whether it's tagged for video, or whether it's tagged for whatever. Okay, we should be able to do that. All right. It's like someone was raising a hand. A question. Okay, I think the hand is down. All right. So that is that about voice tagging. Now, if you run the show interfaces, for instance, for this fast Ethernet 0/19 switch port, it's going to give you whether the switch port is enabled, and it will tell you the mode, it will tell you the operational mode, it will tell you the encapsulation that is done, and importantly, it will tell you the VLAN that particular port is connected to, and the native VLAN for that particular port. Okay, the native VLAN for that particular port. So what we are saying is that it is possible to have more than one native VLAN. You can have a native VLAN for voice. You can have a native VLAN for some other types. Okay. So how do we configure VLANs? All right. So let's see. If we have a lab activity for creating VLANs, a packet tracer, so we're going to do that. But these are just the steps in case we want to know. The first thing is that you enter your global configuration mode from your privilege mode by configure terminal. Then you will now type VLAN space, then your VLAN ID. All right. Your VLAN ID can be, you see, you can use it maybe VLAN 10, VLAN 20, VLAN 100, VLAN testing, and so on and so forth. But from VLAN 1002 to 1005, they are reserved for legacy VLANs. Okay? They are reserved. They are automatically created and they cannot be deleted. Look at it here. All right? Look at it here. So when you are creating, you should not create this one. You have over 4,000 VLANs that you can create, but not with this. So I can say VLAN then 300, VLAN 900, VLAN 800. You can create your VLANs, VLAN this. Then you now name the VLAN. You say name and then you give it a particular name. Then you end, you exit. That is all. As simple as that. So the two key commands is that in your global mode, you just go to VLAN, then you give your VLAN ID, then you now name the VLAN and you have created your VLAN. Okay? So for instance, we are creating a VLAN here. So I go to my global mode and then I say VLAN 20. Then the name of the VLAN is what? Students. Then I end. Case closed. So you see, it's not difficult at all. All right. So if you do not name that particular VLAN, the Cisco iOS will give it a default name of that VLAN and the 4-digit number of the VLAN. E.g., for instance, it will give you VLAN 0020 for VLAN 20. That's going to be the name of that. So it's always advisable for best practices to name your VLANs. So when you create your VLANs and you name your VLANs, how do you now assign ports? Because the VLANs you have created it logically in the switch. So you need to assign certain ports. I have probably a 24 port switch. So you need to assign those ports to those particular VLANs. All right. So the first thing you do is you enter into your global mode as usual. Then you go to your interface. Then you select the port number that you want to do. Interface fast Ethernet 01 or fast Ethernet 02 or fast Ethernet 0, whatever interface you want to use. Then you say switch port mode access. Why are you doing this? Because you need to configure the port to know that it is an access port. You know, you can configure an access port and you can configure it as a trunk port. So what is the mode? You can also configure it as transparent. All right. What is the mode that you are configuring it? So for VLAN, you need to create it as what? Access ports. All right. So you now create your VLAN, you enter your interface for that port. Then you now switch port mode access, then switch port access VLAN 10 or access VLAN, whatever, the VLAN port number that you want to create. So an example is, I just say configure terminal interface fast Ethernet 0/18, which is this particular port here. Then I say switch port mode access, then switch port access VLAN 20. All right. So on the device, it's assigned a VLAN. Then the end device will need the IP address information for that VLAN. All right. So here the student will receive this particular IP address that belongs to that particular student VLAN. So an access port may only be assigned to one data VLAN. However, it may also be assigned to one voice VLAN for when a phone and an end device are off the same port. All right. So that's what we are talking about. So we have an example here. I say, for instance, VLAN 20. That's in my global configuration mode. I name it as what? Student. Then I say VLAN 150. I name it as what? Voice. So these are two VLANs that I have created. All right. Student VLAN and voice VLAN. Now we now move the ports into it. So we come here. We say switch port mode access. Switch port access VLAN 20. For which port? Fast Ethernet 0/18. Then MLS QoS trust. Then switch port access VLAN 20 for this. Then MLS QoS trust COS, so that switch port voice VLAN 150. Now, why do I need this particular command for the same port 18? It means that I want to convey both voice and data on the same particular port. All right. So in addition to assigning the data VLAN, we can also assign the voice VLAN and turn on quality of service for the voice traffic to the interface. The newer Catalyst switch will automatically create the VLAN if it does not already exist when it is assigned to the interface. All right. So here we do show the use of the MLS quality of service trust command. All right. And that is the command that you use so that you can convey both of them on the same platform. So we'll do the packet tracer for that very soon. All right. So the show commands are very simple. You can say show VLAN summary or show interface VLAN 20 or whatever. So if I do show VLAN summary, it will give me the number of existing VLANs on my device. It will give me the existing number of VTPs, VLAN trunking protocols, and then the number of existing extended VLANs. All right. If I do show interface VLAN 20 on a particular port, VLAN 20 is up, line protocol is up because it's going to see it as an interface. All right, as an interface, it will tell us the bandwidth and every other thing. Okay. Now change port membership. All right, change port membership. for instance, here, we say there are a number of ways you can change VLAN membership. Re-enter the switch access VLAN and then the VLAN ID. Use the no switch port access VLAN to place the interface back to VLAN 1. And then use the show VLAN brief or the show interface VLAN 0/18 switch port. Okay, all right. Switch ports commands. All right, use the show VLAN brief or the show interface 0/18 port command to verify the correct. So what we are saying here is that under this particular command, for instance, show VLAN brief, I have my default VLAN 1 and I have all the ports that are here. Okay, now I have VLAN 20, which is a student VLAN, and I wish to move this particular port 0/18 to this particular port. So if I use my switch port access VLAN 20, this port is going to move from here to here. But the moment I use the no switch port access VLAN 20, is going to take it back to the default VLAN. Okay, that is how you can remove it. So how about if you want to delete a VLAN? Delete VLANs with the no VLAN ID, for instance, no VLAN 20 command. All right, but there's a caution before deleting any VLAN. Before deleting any VLAN, assign all the member ports to a different VLAN. Are we together? Before deleting any VLAN, assign all the member ports to a different VLAN. Then delete all the VLANs with the delete flash VLAN.dat, all right, or delete VLAN.dat command. If not, you just delete the VLAN, but it is still there within the configuration file. All right, so after you delete the VLAN.dat, then you can reload your switch, and then everything will be back to normal. All right, so let's do this particular packet tracer activity for
Can I disturb you a bit?
VLANs.
Can I disturb you a bit? Hello?
Where is it?
Hello?
Okay.
Hello? Sati, can I disturb you a bit here?
So we want to do the packet tracer
Hello?
for creating VLANs. All right. So this is the activity. So in this activity, we have basically 3 parts. All right. We verify the default VLAN configuration. That's in part 1. Then configure the VLANs in part 2. Then assign VLANs to ports in part 3. All right. That is what we have here. All right. So the background says VLANs are helpful in the administration of logical groups, allowing members of a group to be easily moved, changed, or added. This activity focuses on creating and naming VLANs and assigning access ports to a specific VLAN. So that's what we are going to do now. So step 1, verify. Part 1. So we are going to verify the default configurations.
Sorry, Sati.
So,
Sorry.
we have 3 switches.
Sorry, hello.
Switch 2, 1, and 3.
Guys, sorry.
On switch 1, issue the command that would display all VLANs configured. By default, all interface would be on VLAN 1. All right, so you remember the commands we talked about. We can always go back in case you forget. But, all right, we enable. Then we say show interface VLAN brief.
I think some
VLAN brief. Show VLAN brief. So if we do show VLAN brief, this is like the default. Can you see? All the port 1 to 24 as well as the gigabit Ethernet interfaces are all on VLAN 1 and is all on the default. So as it is now, there is no particular VLAN that is being created. Okay, so we have verified. So verify connectivity between PCs on the same network. PC 1 and 4. Where is PC 1? PC 1 is here. Where is PC 4? PC 4 is here. They are both on VLAN 10. If VLANs have not been created, then they will not be able to communicate amongst each other. But let's try to communicate between the two of them and let's see. So if I come to PC1, under PC1, what is the IP address here? Okay, just give me just a minute. Let me attend to boss. Just a minute, please. Okay, sorry for that. So what we are saying is that we want to verify PC1 is able to reach out to PC4. All right, so we can run a ping and see if there is no, they are on the same VLAN, VLAN 10 here, VLAN 10 here. So I'll pick PC1 and then command prompt, and then PC4 IP address ping is 172.1.7.10.24. All right, and I can ping. Look at it. I can ping PC4 here from PC1. Okay, what did I say? Ping PC2, and can PC2 ping PC5? PC1 can ping PC4, correct? Yes, it can ping. PC2 can ping PC5, okay? PC3 can ping PC6. Pings to the host on other networks fail. All right, on other networks, that is, this is 172.17 network, 17.10 network. This is 172.17.20 network. So let's ping from here to here and see whether we'll get a response. So if I ping, I'll ping PC2 as 172.17.20 20.22. Unfortunately, I will not get response. There is no reply. There is no response to this. All right. So that's what they are telling us in the verification. What benefits can VLAN provide to this network? All right. So let's see how we can go. So create and name VLANs on switch 1. So I am on PC1. So this is switch 1. So we're going to create. Why is it that okay, let's go ahead. Create and name VLANs. So we'll create VLAN 10 and call it faculty/staff. All right. So let's get into it. So we go to our global mode, configure terminal. Then we will say to create VLAN, we say VLAN 10. Then name is what? Faculty/staff. Okay. Then it says we should create the remaining VLANs. That's VLAN 20, VLAN 30, VLAN 99, VLAN 150. So let's create it. Okay. So VLAN 20, what is it named? Students. Okay. VLAN 30, what is it named? Guests. Default. I think that's how they put it. Okay. VLAN, what else? 99. What do we call it? Management and native. Management and native, right? Then VLAN 150. What do we call it? Voice. All right. Oh, sorry. Let's call it name voice. Okay, so we have done A, we have done B. Step 2 says verify VLAN information. So show VLAN brief. Okay, so now you see we have these VLANs that we have created. VLAN 10, VLAN 20, VLAN 30, VLAN 99, and 150. And all the ports are still located in VLAN 1. Okay, all the ports are still in VLAN 1. So what we'll do now is let's go to the next activity. Create the VLANs on switch 2 and switch 3. Okay, so this same VLANs that we've talked about, create it on switch 2 and switch 3. Switch 2 and switch 3. All right, so enable, configure, config T, then VLAN 10, name is faculty staff. VLAN 20, name is students, right? All right, VLAN 30, name is what? Guests. Guests. Okay. And VLAN 99, name is management and native. Okay. Then it's VLAN 150, name is voice. All right. So this is what we have in this. Okay. And so this is switch 2. So we now go to switch 3. Go to switch 3. Enable, configure terminal. VLAN 10. Name is faculty staff, right? Then VLAN what? 20. Name is students. Sorry. Name is students, right? Then VLAN what? 30. Name is what? Guests. Defaults. Then VLAN 99. Name is management and native. Okay. VLAN 150. Name is voice. Okay. So we have done that for switch 2 and switch 3. Do the same command, step 1 to create this. Then verify the implementation. Then, okay, so let's verify. So if I do, and so show VLAN, sorry, brief. Okay, so we have our VLANs. They're all here, but there are no ports. So we're to assign ports. Okay. So to assign ports, assign the interfaces to access ports and assign the VLANs as follows. So VLAN 10 to fast Ethernet 0/11. All right. That's for switch 2. All right. Then VLAN 20 for port 18. Then VLAN what now? 30 for port 6. So let's go to here. So config and then interface. So we enter the interface. Interface fast Ethernet 0/11. Right? All right. Then switch port mode is what? Access. Then switch port access VLAN 10. All right. Then we go to port 18. Interface F0/18. Then we go switch port mode access. Then switch port access VLAN what? 20. Okay. Then we go exit the interface. We go to interface 06 F0/6. Okay. Then switch port mode access. Switch port access VLAN what? 30. All right, we're there. So it says we should assign VLANs to switch 3. Use the same access port management on switch 2. Configure interfaces as access ports and assign the VLAN as follows. All right, this is now switch what? 3. So we go to switch 3. Switch 3, config terminal, then interface F in 0/11, switch port mode access, switch port access VLAN 10, then interface F 0/18, switch port mode is access, switch port access VLAN what? 20, yeah, VLAN 20. Right? All right. I think so. Then exit. Then interface F0/6. Switch port mode is access. Switch port access VLAN what? 30. Good. All right. So we have done for switch 3. Now they say assign the voice VLAN to fast Ethernet 0/11 on switch 3. All right. So it says, as shown in the topology, switch 3, where is the topology? Look at it. This is switch 3. It has a voice over IP phone, which is now connected here. So you see they're all on the same port. So we need to configure these ports to carry both voice and data here. All right. So on the topology, switch 3 fast Ethernet 0/11 interface connects to a Cisco IP phone. The phone contains integrated 3-port 1000 switch. One of the ports on the phone is labeled switch and connects to the fast Ethernet 04. Another port on the phone is labeled PC and is connected to PC4. The IP phone also has an internal port that connects to the IP phone functions. So we are supposed to now connect this. So I will now exit interface F0/11, then MLS, quality of service, trust, US. All right, then switch port, voice, VLAN 150, right? Right, so they now say we should verify our configuration and then we will check. I hope we have done everything rightly. All right, so let's verify. Show VLAN brief. All right, so this is what we're expected to see. So I come to switch 2 and show VLAN brief. Okay, I have this. So you see here, I have faculty has 11, port 11, port 18 is in students, guest is in this. Okay, I think we need to add let's see what we have on port on switch 3 and VLAN brief. Okay, aha, so you see we have a voice on port 11 here as well. So I guess we should add the same command for all. All right, the other VLANs, the appropriate VLANs. Let's see. Let's go to switch 2. Switch 2. Config terminal interface F0/11. Okay. Let's trust this switch port voice VLAN 150. Is it supposed to do? Oh well, we asked to do that anyway. Let's verify and see. Yes, sir. Excuse me, please. Okay, I'm back now. All right, so let's check our activity and see what we've done right and what we've done wrong. Let's check results. What did we even score? I don't know. Okay, we'll check. What did we score? All right, all these are correct. Okay, we have 90/94. Item 21/22. That means there's one item we have not done right. Let's check. Oh, VLAN 99. The name is incorrect for switch 2. Okay, switch 2. Okay, let's go to switch 2. Let's go to switch 2. VLAN 99. Let's end here. Show VLAN brief. Oh yes, see our problem? I think the spelling of management, we didn't spell it correctly. So let me come to configure terminal. Sorry. This, where is the name? I think where is it? Management native. So that's VLAN 99. Name is management and native. Okay, so management and native. So let's check our results now. Okay, 94 over 94 and 22 over 22. So let's check. So, the name is correct. So currently now, I think we have successfully configured our VLAN and everything seemed to be fine with it. All right, so let's continue with the class. Let's continue. Now, VLAN trunks. All right, so we're supposed to configure a trunk. How do you configure a trunk? You go to your global mode, global configuration mode, and from your global configuration mode interface, then you give the interface ID. That's the interface, the port that you want to use or configure as trunk. The port you want to configure as trunk. Then you now go to switch port mode is what? Trunk. Okay, remember the other one, switch port mode is access. Now switch port mode is trunk. Then switch port trunk native VLAN, then 99 or whatever VLAN we want to use, we have configured as native. Then switch port trunk allowed VLAN, then you give the VLANs that you want to allow them to pass their traffic through this particular trunk port. Okay, then you end. Okay, so this is an example of it. So switch port trunk mode trunk for this interface. Look at it, this interface here between this switch and this switch. So this interface here, so switch port mode trunk, then switch port trunk native VLAN 99, because VLAN 99 is the one that we have configured as the native and management. Then switch port trunk allowed VLAN 10, 20, 30, 99. So I'm allowing these particular VLANs to convey traffic using this. If you notice, there is no VLAN 150. All right, or we'll find out, or whatever VLANs that we want. All right, so it says, notice in the switch, initial fast F0 port 1 command is set to trunk administratively. All right, so if we do interface fast Ethernet 0/1 for switch 1 here, switch port mode trunk, no switch port trunk VLAN 99. All right, here it says it is set to trunk administratively, is set to trunk operationally, that is functioning. Encapsulation is .1Q, and native VLAN is set to VLAN 99. All VLANs are created on this switch will pass traffic to the trunk. So we have also an activity that will do that. So we use the no switch port trunk allow VLAN 99 to remove it. All right. Anytime you want to reverse a configuration, you want to remove a configuration, you just put no in front of the command. That's how to reset your trunk. So let's do the packet tracer activity for that. Configure trunk. Okay. Okay, this is the activity. So we're going to verify VLANs and then we're going to configure trunk on this particular activity. So verify VLANs. So we display the current VLANs on switch 1 and then on switch 2 and 3. So if I come to switch 2 here, let's verify. If I say show VLAN brief, okay, so we see you have faculty is VLAN 11, faculty staff, students is in port 18, then guest is in port 6, okay, And what else? What else? What else? Yeah, these are the VLANs we have. Now, verify loss of connectivity between PCs on the same network. So PC1 and PC4 are on the same network. Where are they? PC1 and PC4. Initially, we tested and they were fine. There was a response. Now let's ping and see what happens now. Okay. Now, so if I ping 172.170.10.21. Oh, sorry, I am pinging something. .10.24. 10.24. I'm pinging 10.24, which is PC, this PC4 here. And I'm getting a request timeout. Okay, I'm getting a request timeout. So we have confirmed that there should not be, because there is no trunk configured here. Okay, there's no trunk configured here. So we're going to configure the trunks here, and then we'll see about that. So they said we should configure G01 and G02 interfaces on switch 1. All right, we configure them as strong. All right, so how do we go about? So I come to switch 1. Configure, and now I'm going to use the command interface range because I want to combine more than one physical interface and apply the same configurations on them. G0/1 to 2. Sorry, interface range. Interface range. Very good. Okay. Then switch port mode is what? Strong. All right. Is strong. Switch port mode is strong. That is what we've been assigned to do for A. And B says configure VLAN 99 as the native VLAN for these interfaces. All right. So I'll now say switch port strong native VLAN 99. Okay. All right. So we have configured VLAN 99. All right. So what is the next thing? We verify the trunking. All right. So if I show interface trunk, good. See my trunk here. All right. My trunk is VLAN 99. All right. Where's my trunk port? Aha, look at it. This is what I'm looking for. How did I know? 802.1q. 802.1q. And the native VLAN is what? VLAN 99. Okay. All right. So then what else did they say we should do? Verify this. Use the show interface strong command. To confirm that this has successfully negotiated switch 1 and switch 2. The output also display information about the trunk interfaces on switch 2 and 3. All right, so correct the native VLAN mismatch on switch 2 and switch 3. Where is the mismatch? Can you see native VLAN mismatch discovered? All right, reason is because we have not configured it on switch 2 and switch 3. This is switch 1. So switch 1 is having a miscommunication between switch 2 and switch 3. So native VLAN mismatch, and see how the information goes. Native VLAN mismatch discovered on gigabit 0/1. This is switch 1 with switch 2 gigabit 0/1. Yeah? So you see in switch 2, it's showing that the native VLAN is VLAN 1. In switch 1, it's showing the native VLAN is VLAN what? 99. Okay? And the same thing with switch 3. So what are we supposed to do when we have this problem? We go to switch 2 and switch 3 and then make sure that their native VLANs are what? Are VLAN 99. All right? So that's why step 3 says configure VLAN 99 as native VLAN for the appropriate interfaces on switch 2 and switch 3. All right? So how do you go about that? You go to switch 2. You see, it's also showing us the same problem. So what port are we supposed to configure in switch 2? Like, look at it, gigabit 0/1. All right? So we're going to enter config T, interface G0/1. Then we say switch port mode is what? Strong. Switch port mode is strong. Then switch port strong native VLAN 99. All right, good. So look at it. It has been restored. So we now go to, we come to this switch. I think it's gigabit 0/2. Then we say configure enable, configure terminal, then interface G0/2. Right. Switch port mode is what? Trunk. Switch port trunk native VLAN 99. Good. So you see, it has been restored. Okay. So you see, you will not see those problems again. So now, if I ping from PC1, I should be able to reach PC. So you see, we're having a timeout. If I run the command, we should have a reply now. Can you see? So it means that the problem has been rectified. Problem has been rectified. And so we are good. So let's check our activity. What did we score? Let's check our results. Assessments. Okay, look at it. Score 80/80. And we have 8/8. Oh, that's good. So, all right. So we are good. So that's the end of this activity. All right. So, all right. There's another activity. Let's go to, where is it? Sorry. Dynamic trunking protocol. All right. Dynamic trunking protocol, DTP, is a proprietary Cisco protocol, and it has these characteristics. By default, it is on 29, 60, and 50 switches. Dynamic auto is default on 29, 60, and 50 switches and may be turned off with the non-negotiate command. They may be turned back on by setting the interface to dynamic auto. Switching a switch to a static trunk or state access will void negotiation issues with the switch port mode trunk or switch port mode access command. Okay, so these switches automatically negotiate as trunk. It will not be giving you those errors. If you want to remove it, you can say no negotiate. All right, so we're going to configure it. We have a lab activity on that, and that will be the last lab that we'll take today. The remaining labs, I will encourage you to take on your own. Okay, take on your own. So, if I enter switch 1, switch port mode trunk, switch port no negotiate. So I'm removing the auto negotiation. That's I'm removing the dynamic, the GTP, whatever. So I'll now say switch port mode dynamic auto. That is if you want to enable it. All right. And now let's look at this description. If I set a port to access, that's permanent access mode and negotiate to convert the neighboring link into access link. All right. If I send it to dynamic auto, it will become a trunk interface if the neighbor interface is set to trunk or desirable mode. If I send it to dynamic desirable, activity seeks to become a trunk by negotiating with other auto. Okay, just a sec. Let me attend to. Okay, let's continue. All right. So if I send a switch to trunk, permanent trunking mode, and negotiate to convert the neighboring link into trunk link. So what we are saying is that if you set up your interface port to, this is where our interest is dynamic auto or desirable. Dynamic auto, the GTP that we're talking about has to say that um, it will automatically convert it to trunk when the need arises. All right, especially when the interface is made to desirable. All right, so look at this result of a DTP configuration. DTP configuration options are as follow. If I have dynamic auto, that means I can have dynamic access, then desirable will be trunk, trunk would be trunk, access would be access, but dynamic auto would be access. If I have dynamic desirable with dynamic auto will give me trunk. Dynamic desirable with dynamic desirable will give me trunk. Dynamic desirable with trunk would give me trunk. Dynamic desirable with access would give me access. Then trunk with dynamic auto will give me trunk. Trunk with desirable will give me trunk. Trunk will give me trunk. Trunk with access, limited connectivity. Then access with auto will give me access. Access with dynamic desirable access. Access with trunk with limited. Access with access. So now this is the summary that you see access ports and trunk ports. Look at their results. For access ports, all of it will give you access, except if the other one is trunk, you will not be able to connect. Trunk, all of it would be trunk, except the one for access that will give you, what do we call it? Limited connectivity. Now, but you see, desirable, all of it will give you trunk, except when you have desirable to be access. Then dynamic auto will give you access if dynamic auto is going with dynamic auto. If both switches have been configured for dynamic auto, you have access ports. If both switches one switch is configured for dynamic auto, the other one is access, it will give you access. But if one switch is dynamic auto, the other one is either desirable or trunk, you get a trunk. All right. So if you show GTP interface, it's going to give us the status. Now let's do the packet tracer for it, and that will be the end of today's class. So let's launch the packet tracer. Okay, it's loading. Okay, I think this is it. And, this is the activity. So we're supposed to configure a dynamic trunking protocol. Okay, so we configure static trunking, and then we will configure and verify GTP. All right, so let's verify on switch 1. If we do show VLAN brief, switch 1. Sorry. Let's switch 1. Yeah. Switch 1. Show VLAN brief. Okay. So this is what we have. All right, and it's exactly what we have here. Then we create additional VLANs on switch 2 and 3. That's switch 2 and 3. Switch 2. Enable configure terminal. We create VLANs. Right. So we say VLAN 10. Name is red. Okay, VLAN 20, name is blue. VLAN 30, name is what? Yellow. Okay, so we go to switch 3 and do likewise. Enable VLAN 10, name is red. VLAN 20, name is blue. VLAN 30, name is yellow. Good. All right, so we have created the VLANs. Create VLANs 10, 20, and 30 in the table below. Good. Verify the addition of the new VLANs. So, by so show VLAN brief. Okay, so we have these VLANs that we have created. Okay, that's good. Then, in addition to the default VLANs, which VLANs are configured in 2? In switch 2. Right? Let's see. Switch 2. The other VLANs are 99, 999. Okay, these are other VLANs that have been created. All right. Then repeat the same for switch 3. We've done that. Then assign ports. Okay. So on switch 2, we have to put fast Ethernet 0, 1 to 8 on red. Switch 2, interface range F0/1 to 8. Switch port mode access, right? Switch port access VLAN 10. Okay, we are on switch 2. Then exit. Then interface range F0/9 to 16. To 16. And switch port mode access. Switch port access VLAN what? 20. That's the blue VLAN. Then go to interface range, first internet 0/17 to 24. Switch port mode is what? Access. Switch port access VLAN what? 30. Okay. So exit. Switch 2. Then we do that for switch 3 as well, right? Yes, switch 3. Configure terminal. Let's see the ports. Then interface range, switch 3 F0/1 to 8. Switch port mode, access. Switch port access, VLAN 10. Interface range F0/9 to 16. Switch port mode is access. Switch port access. VLAN what? VLAN 20. Yeah, VLAN 20. Then exit. Then interface F0/17 to 24. Oh, sorry. Interface range. Okay. Switch port modes access. Switch port access. VLAN what? 30. It is the yellow VLAN. Okay, so we have done that. What's the next thing we should do? Assign for 3 we have done. Now you have ports assigned to the VLANs. Try to ping PC1 to PC3. And let's see, where's PC1? We have to ping PC3. Okay, PC1. What's the IP address of PC3? Let's check. PC3 is 30.1. Yeah, 192.168.30.1. Let's check it. It is PC1, PC3. So we're pinging 192.168.30.1. Okay, we don't have a response. Okay, it's timing out, which is, I think, which is good. And then what did they say we should do again? Let's check. We should, okay, configure trunks on switch 1, switch 2, and switch 3. So on switch 1, we'll configure it as dynamic desirable. That's G01. That 01 is coming to switch 2. So configure terminal. So interface G0/1. Switch port mode dynamic desirable. Okay, so we have set it to desirable. Remember the analysis we did. If we set one to desirable and the other one is trunk, we should have trunk. If it is where is that table? Let's see it. Okay, if it is desirable, if we set it to auto, the second one we should have trunk. If we set it to desirable, we'll have trunk. If we set it to trunk, we have trunk. Every other thing is trunk except what? Access. Okay, that's what it means. So let's go back to the activity and see. All right, so what will be the result of trunk negotiation between 1 and 2? Right now, 1 and 2, if this port is accessed, that means you will limited connectivity. All right, but if it is any other thing, it will be trunk. So on switch 2, verify that the trunk has been negotiated by entering the show interface trunk command. Should appear in the output. So show interface trunk. Okay. Look at it. G01 should appear in the output, which is correct. So what is the mode? The mode is auto. All right, that is the mode. The mode is auto, which is good. What is the mode of the status? Okay, the status is trunking. All right. So what next? For the trunk link, switch 1 and switch 2, configure interface gigabit 0/2. Where are we? All right, for the trunk link, switch 1 and switch 3, configure interface gigabit 0/2 as a static trunk on switch 1. In addition, desirable DTP negotiation on G2 on switch 1. All right, so we go to switch 1. Okay, we're in switch 1. Switch 1. Right, so we go interface G0/2. Switch port mode as what? Trunk. Then switch port no negotiates. Okay. So now if we do show dynamic trunking protocol, let's see. All right, that's good. So we have verified. The next thing now we need to do is to configure VLAN 999 as the native VLAN for the links on switch 1. Okay, so configure terminal. We say interface range G0/1 to 2. Okay, switch port from native VLAN 999. All right, and then on switch 2 and 3, configure 999 as the native VLAN as well. So where's switch 2? We come to switch 2. Which port are we using? This 0/1, right? All right, so let's say config G0/1, and switch port from native VLAN 999. All right, that's switch 2. We will go to switch 3. Switch 3 is 0 what? 02. Okay, so interface G0/2, switch port from native VLAN 999. Okay, good. They say we should do that on this and this. We have done that. Attempt to ping PC1 and 6. PC1 to 6. What is PC6? What's the IP? 192.168.10.2. So Okay, 192.168.10.2. Okay, let's see our results. Time out. So let's see. They said attempt to ping 126. Why was the ping unsuccessful? All right. Why was it unsuccessful? They said look at the show VLAN brief output on all the switches and compare the outputs. Okay. So this is PC1 and PC6. See as it is now. PC1. Right. VLAN brief. Okay. Show VLAN brief. Okay. PC1 is under what port? Okay. Let's see which VLAN is it correct. Which VLAN? This is red. VLAN 10. Yes, so it's VLAN 10. Right. So I think the problem is the trunk. So that's why it says reconfigure the trunk on switch 3. That's why you see this amber. So here, reconfigure the trunk command. All right. Issue the show interface trunk on switch 3 and let's see what we've got. Show interface trunk. There's no trunk link here. Okay, there's no trunk link. So what is the mode? What is the mode and encapsulation? There's even no information. Okay, it's coming up. See native mismatch. Can you see mismatch on gigabit 02 here is on VLAN 1. That is, and then the other one is 999. So we need to resolve. This is where the problem is, right? All right. So configure G02 to match G02 on switch 1. So that means on switch 2, we need to configure native as what? VLAN 999. Okay. So we come in here. Config T. Yes, sir. Fine. Oh, okay. Just a minute. All right. So, guys, give me just 1 minute. I'll join you guys. Yeah. But I'll be with you in a minute. All right. So now I'm going to now just do we're on config T. Good. So interface G0/2. All right. Now we are supposed to configure switch port mode as trunk. Okay. Then the native VLAN. All right. Switch port trunk native VLAN 999. Okay. All right. So we should have the same information as that. So just a minute, let me just respond to my boss. We had a power issue, I was just trying to resolve it. Okay, that being said, let me just quickly, where were we? In the activity, let's check. Where did we stop? Let's check our activity. Okay, 21/25. Okay, VLANs. Okay, we need to configure our VLANs on switch 1. Right, so we have not done that. So I think that's that one on switch 3, the non-negotiate. All right, so let's do that, and then we will end today's class. Okay, switch 3. All right, configure terminal. G0/2. Coming. Oh, sorry. With switch 1. We're supposed to create the 3 VLANs. Enable show VLAN brief. Let's see. Okay, so we're to configure VLAN 10, 20, and 30. Let's see the details we have been given for that. Where is the details? All right, look at it. VLAN 10. Name is red. Is it VLAN 20? Name is what? Blue. VLAN 30. Name is yellow. Okay. So so show VLAN brief. Okay, so we have VLAN 10, 20, and 30. Then we said we're supposed to do the non-negotiate command in the, I think switch 3. All right, so let's go to switch 3. Switch 3. Switch ports non-negotiate. So we have done that. Now let's check our results. Okay, we have 100%, 61/61, 25 item out of 25. All right, so we are good in this activity. I think this is where we'll come to a stop for today's class. We're able to look at switches and their forwarding methods, and then VLANs, and then their trunking protocols. And I think that's a good activity we've had today. We have some other activities of which I encourage you to go and do on your own. Okay, so is there any question? If there is, you just send it to the WhatsApp group or to the Cisco WebEx team group. See you by next class on Thursday. Thank you very much. Have a lovely day. I'm going to beside you. Yeah. The capacity.